Interacting with the digital world isn't a new concept. Films like Tron 1982 and Spy Kids 3D 2003 have introduced it to life on the big screen. These same customers now can communicate to their online realm in today's globe. There are different uses for this sort of modern technology, ranging from entertainment and social media to learning and marketing. You've probably already had an immersive experience without even realizing it. But first and foremost, what is VR technology? After decades or even centuries, how sophisticated will virtual reality be? And what is the most reasonable route to take to get there? So watch this video all the way to the end to learn more about the incredible developments in virtual reality technology. Hello guys, welcome back to AI Universe. We are back again with a new video. Make sure to subscribe to our channel and hit the bell icon to get notified about the updates. Virtual reality, VR, is a virtual experience that can be both comparable and dissimilar to the actual world. Entertainment, especially gaming consoles, learning, including clinical or army training, and business are all examples of virtual reality applications, such as virtual meetings. AR technology and mixed reality, commonly known as extended reality or XR, are two further sorts of VR-style technologies. 8K VR headsets will be commonplace by 2030. The most advanced VR screens will have an 8K resolution, which is 4 times as many pixels as a 4K screen. There is no noticeable pixelation while seeing character models and items real close with all these gadgets, resulting in astonishing detail and realism. VR games also offer near-zero lag and a broad field of view thanks to other equipment enhancements. Many VR headsets will have the possibility for brain-computer interfaces in 2030, which would record users' electrical impulses and allow them to perform tasks simply by thinking about them. For general brain-computer interface use, headgear and fitness bands with non-invasive detectors become the favored options. The wearer's mental intents are converted into actions by scanning beta, gamma, as well as other neural frequencies engaged in problem-solving and navigation tasks. The signals are not processed by the brain-computer interfaces. Instead, they are sent to console games that decode the data. Game developers and providers of virtual reality entertainment can also track and evaluate the emotional responses of individuals who contribute that data. This enables these businesses to produce more engaging content experiences in the future. However, these gadgets have limited capability, and handling things in digital realities and video games remains a challenge. Virtual worlds will be significantly larger than ever in 2030. VR environments that are extremely vast and detailed are now possible. This is due in major part to the introduction of 6G, which would be 100 times faster than 5G and can transfer terabytes per second. This is important because a growing number of virtual reality consumers are turning to cloud gaming providers. 16K virtual reality headphones will be commonplace by 2050. Most headsets will have 16K resolution as standard by 2050, which is 4 times the number of pixels as 8K screens from 2030, and far more than 16 times the picture elements as 4K displays from the mid-2020s. The 16K format provides photorealism that is nearly impossible to differentiate from the real world with the naked eye. Meanwhile, in the early 2020s, a mid-range GPU has far more than 10 petaflops of computing power, making it 1,000 times more efficient than high-end graphics processors. Brain-computer features have enhanced by orders of magnitude around 2050. All wearable technology with VR will include some form of brain-computer interaction. In the 2030s, the relatively specialized and speculative brain-computer connections are being substituted by considerably more advanced ones that reduce the noise in brain signal data. Bidirectional information sharing is now possible with the brain-computer connections. These powerful neurological interfaces send impulses to the brain, allowing the user to experience visual, auditory, and other sensations. Because they rely on the anatomy of the brain, the sights and sensations generated by these gadgets are nearly indistinguishable from reality and are unique to each user. Using your brain impulses, you can effortlessly manage any substance in a game. This is especially crucial in the new Star Wars game, in which you operate as Jedis and Siths with powerful skills. You can also play like the One in the most recent Matrix game. Furthermore, these technologies enable persons participating in virtual reality games and activities to interact with one another with relatively simple ideas. This feature, however, will consider taking another few years to perfect. Virtual worlds will be far more realistic in 2050. With the advent of Unreal Engine 8, game studios and individual producers may now develop big and realistic virtual towns that are a completely open world in terms of stores, commercial spaces, and many other types of interiors, quicker and faster than ever before. Similarly, a complete forest may now be recreated with sub-millimeter accuracy, revealing unique and random details like specific leaf marks or bug bites. Character models reflect this range and realism as well. GANs, generative adversarial networks, can generate an almost unlimited range of facial features, hair, body kind, and apparel. The massive volumes of data given to artificial neural networks makes this possible. Character gestures, attitudes, and actions are also improved using this technology, rendering them more liquid and lifelike. Character animations aren't completely realistic at this point, but they're close. And with the current version of MetaHumans, it's simple to create hundreds of non-playable individuals at once, each with their own personality and backstory. Non-playable characters may now generate and sustain lifelike, complex, and indefinite dialogues using sophisticated and adaptive deep learning software in the cloud, due to a current version of a language model comparable to GPT-3 from the early 2020s. In general, the audio is deeper, more atmospheric, diverse, and realistic. As sound waves bounce about virtual worlds and are impacted by multiple objects, textures, and weather patterns, they may be adjusted in precise detail. Grand Theft Auto 8, which features a VR option, makes use of a lot of this technology and grossed billions of dollars on its first day of release. VR in the 2030s. The augmented reality feature allows you to see holograms via transparent lenses. The lenses in the mixed reality mode will be transparent as well, allowing you to view hyper-realistic virtual things in the real world that appear to obey physics. The interactive virtual mode applies an opaque silver covering to the glasses, allowing you to fully immerse yourself in a virtual world. In the augmented reality and mixed reality formats, you may see a smart stream, where you can use your brain activity to handle numerous apps and data. Because of these characteristics, VR glasses are regarded as the next revolutionary step after smartphones. Virtual reality headsets have come with earsets that are nearly invisible and use bone-conducting technology. Another field that is slowly gaining traction is virtual reality contact lenses. Lifelike feel, aroma, and tasting are now possible in 2050. Exoskeletons are currently used in VR technology sensory suites to replicate touch, or nerve terminals may be stimulated to create muscle spasm. You may sense sensations like cold and heat on body locations with sub-millimeter precision thanks to this technology. In a virtual world, you can tell the difference between being punched and being caressed. You can also experience the impression of a mild breeze or swimming through a simulated lake. Smell and taste, in complement to tactile technologies, have been digitized. Virtual environments are starting to include digital odors and tastes, which are controlled by impulses through brain-computer interfaces. Real-world locations will be used for virtual reality experiences in the year 2050. Multiple companies have constructed digital representations of real towns and locales as part of a huge attempt to build viable metaverse ecosystems. This enables more seamless transitions between physical world location-based holograms and virtual world actions, and vice versa. This was made possible well before 2050 thanks to advancements in GPS, 3D scanning, and AI technology. Real-world sites are increasingly being used as backdrops in virtual reality games. The virtual tourist business is also transforming because of this growth. This trend will continue in the future as computers get more sophisticated and powerful, to the point where we will no longer require physical devices, such as smartphones or laptops. Within a few years, virtual ones will supplant our cell phones. They will become a piece of neurons instead of being connected to our bodies, via connections or wires. It is already occurring with products like Google Glass, which allow users to control their glasses only through their thoughts. Due to metaverse innovation and entry into the virtual reality realm, we feel that it will not be long before these types of devices become available to everyone at inexpensive costs. We predict this will arise within 10 years at most. Is the future with VR technology going to make wonders? Will VR change the present education system? Is VR going to be the future of gaming? Let's wait and watch. This is us signing off. We'll see you in the next one. Until then, peace.